Good afternoon, everyone. In the previous class, we discussed about ensemble. What is the ensemble? So now, today, I am going to teach you the different types of ensemble. There are three different types of ensemble, as you know. This is the micro-canonical, canonical, canonical, and grand canonical, and grand canonical. These three types of ensemble is there. So, why we need three types of ensemble? Why? What is the importance of this? So, I already teach you a system. Let's suppose this is a system of any particular animal. Let's suppose there is so many gases there. According to the system properties of the system, we define some ensemble here. Ensemble is the connection between thermodynamic and statistical mechanics. Like we create an ensemble for a system, and from this ensemble, let's suppose from this ensemble, we get some thermodynamic parameter. Like from S, we get some S value, and we can get some Helmholtz free energy A value. We can get this statistical, not statistical, this thermodynamic parameter from creating the ensemble. So there is different type of system if we found in our universe. Like this is the system. This is one system, and if its wall is rigid, like let's suppose we define a gas in a container, and let's suppose total number of particles of the gas is constant. When the total number of particle gas will be constant, if the wall is impermeable, let's suppose in this box, this wall is impermeable for this particle, impermeable, and for this case, n will be constant. And let's suppose we take another condition, V is also constant. When V will be constant, rigid, if the wall is rigid. And let's suppose we take another condition, E also constant. And when E will be constant, if the wall is adiabatic. This is the three conditions we impose in a system of gas. This is the system of gas. If we impose this three condition, and we can consider this as macrostate. This is the three macrostate. We restrict this system in this three macrostate. This will remain constant all over the time. So if the system is like this, we connect this system to microcanonical ensemble. So regarding to the different type of restriction, we get different types of ensemble. So there is three types of ensemble we observed in our study. So this is the condition for microcanonical. And what about the canonical? Let's suppose in the same system, we restrict the system now different way. This is some gas particle inside a box. Now here also let's suppose P is constant. Here. So this is the rigid wall. And here suppose T also constant. How T can be constant? If heat can transform from inside to outside of the system, then only T can be constant. So this will be diathermic wall. And let's suppose we again we make constant n value. Total number of the particle is constant here. So this means impermeable wall. So we consider a system where this property is fulfilled. So in which system these three properties will be fulfilled? In a closed system. If there is a system is closed. I hope you already studied this closed system, open system, this type in your BSc or higher secondary. So if this system is closed, then it's linked with canonical ensemble to study a statistical point of view, statistical study. Then we link this system to canonical ensemble. Canonical ensemble. I hope you understand. And in this case, in microcanonical ensemble, the system will be isolated. I forget this to tell about. This will be isolated system. Isolated system will study under microcanonical ensemble. Isolated system. I hope you understand this. What about the grain canonical ensemble? There can be a system which the particle can move from inside to outside also. Like impermeable, this wall is maybe permeable. So this also can be the condition. So this condition happens in grain canonical ensemble. Here mu is constant. Mu is constant here. Mu constant means number of particle can be exchanged. Number of particle can be exchanged. Right. Again here T also constant. T constant means diathermic wall. And again here P constant. P constant means rigid wall. I hope you understand. So these three and this system is open system. This is the open system. If the system is open, then we study this under grain canonical ensemble. So these three types of ensemble is available here. So our main focus will be these two ensemble because there most of the question is come from these two ensemble. Question will be come from here. From here. So I will teach the microcanonical and grain canonical ensemble. Basically, I will teach these two topics. So you already understand what is the ensemble is and what the type of the ensemble. And now I am going to give some relations between ensemble between thermodynamic parameter and microstate in statistical mechanics. So what about them in microcanonical ensemble? In microcanonical ensemble, we get the relation S equal to K, L, and omega. I in the first lecture and second lecture, I told you that through the ensemble, we get some connection from statistics to thermodynamics. This is the thermodynamic parameter. S is the thermodynamic parameter. And this is the microstate. This is the statistical term. This is the microstate, number of microstate. So this is the connection between thermodynamics and statistics. I already told you ensemble is a bridge type. Bridge type which connect thermodynamic term to statistical term. This is the theory behind the ensemble. So this we get in microcanonical ensemble. In microcanonical ensemble, this we get in microcanonical. Why this mainly happens in microcanonical ensemble? Look at this. This mu is the number of particles, total number of microstate. Total number of microstate. And you already know in microcanonical ensemble, total number of particles remains same. So here number of microstate will not vary with time. The possible way the particle can arrange in microcanonical ensemble will remain same. So this formula used in microcanonical ensemble, right? But in grain canonical ensemble, what happened? In grain canonical ensemble, that the same term is A equal to KT ln Q. Ln Q, and here Q is the partition function. So now this term is came. This is the most important term. most important. You should learn to calculate how to calculate partition function. It's the most important. Main question will arise from this part, partition function part. So how we'll get this relation? There is calculation to get this relation. Probably I will teach you in the next video. I'll teach you this relation. But in canonical ensemble, this relation should appear in canonical ensemble. So A is the Helmholtz free energy. Helmholtz free energy. And this is the connection. A is the thermodynamic term and Q is the statistical term. From statistics, we get Q value. Q means partition function from statistics. And this is the thermodynamics. This is the connection here. In the canonical ensemble, this is the connection. This is the connection in a canonical ensemble. So you already learn in microcanonical ensemble, this is the connection. In canonical, this is the connection. And in grand canonical ensemble, the connection is phi equal to minus kt ln z. This is not important that much. Grand canonical ensemble is not that much important. So I will not going much details about grand canonical ensemble. So microcanonical and canonical ensembles is important for your exam point of view. So next time I will teach you the partition function. Next time I'll teach you the partition function. And after partition function, I go do some problem, and after that I will move to some other topic. So I hope you understand all this thing.